Hello everybody, I'm V. Rakasuni, Government Degree College Madras. Today's learning objective is about chromatography. Chromatography in Greek means chroma, color, and graphian is to write and is a collective term for a set of laboratory techniques for separation of the mixtures. This mixture is dissolved in the fluid called mobile phase, which carries it through the structure holding another material called stationary phase. And the various constituents of mixture travel at different speeds, causing them to separate. The separation it is based on differential partitioning between mobile and stationary phase. So, chromatography is an analytical technique widely used for separation and purification of organic and inorganic compounds. The separation technique varies for the substances respective to the relative solubilities in two immiscible phases called chromatography. The important terms involved in this chromatography are stationary phase, mobile phase, and the mixture component to be separated. In this technique, it is a technique used to separate, identify the mixture of components. And it works by allowing the molecules present in the mixture to distribute themselves between a stationary and a mobile medium. Molecules that spend most of their time in the mobile phases are carried along faster. Now, let us see the classification based on the stationary phase. So, the chromatographic methods are classified either on the basis of stationary phase used or the mobile phase used. So chromatographic methods basically divided with respect to stationary phase are solid stationary phase, liquid stationary phase. Solid stationary phase is adsorption chromatography. Liquid stationary phase is partition chromatography. In the adsorption chromatography, the solid is the stationary phase and the mobile phase can be solid, liquid, sorry, the mobile phase can be the liquid or gas. And coming to the liquid stationary phase, the stationary phase, which is stationary, is liquid. The mobile phase can be liquid or gas. And this is partition chromatography. So the gas mobile phase in the stationary chromatography, adsorption chromatography is again of two types, depending upon the mobile phase. It can be gas or it can be liquid mobile phase. So gas chromatography is an example under this category, where the solid is the stationary phase and the gas is the mobile phase. And coming to the liquid mobile phase, a solid stationary phase is used and the mobile phase is liquid. In this category, we are having column chromatography, tin chromatography, ion exchange chromatography. Here, in the column chromatography, thin layer chromatography, ion exchange chromatography, the solid stationary phase is here, the stationary phase is the solid and the mobile phase is liquid. In thin layer chromatography, again, solid is the stationary phase and still the mobile phase is liquid. And it is the same even for the ion exchange chromatography. We have solid stationary phase and liquid mobile phase. Now later, I'm going to explain in detail about these cryptographies. Now coming to the second category, liquid stationary phase, and mobile phase can be gas or liquid. So here, if liquid is a stationary phase and mobile is a gaseous phase, we are having gas liquid chromatography. And this is the partition chromatography. And for the liquid stationary phase, if liquid mobile phase is used, we are having two types of chromatographies. One is the paper chromatography, the other one is the high pressure liquid chromatography. Now, based on mobile phase, again the chromatographies are classified into different types. Chromatographic methods based on the mobile phase are basically of two types. One is the liquid mobile phase, and the second one is the gas mobile phase. So, in this liquid mobile phase chromatographic method, if stationary phase is solid, we are having three types of chromatographies. As previously explained, in the solid stationary chromatography, one is the column chromatography, the second one is the thin layer chromatography, and the third one is ion exchange chromatography. So in the column chromatography, in detail we'll discuss. The column is packed with the solid stationary phase. And in thin layer chromatography, here you're having plate preparations. There the solid stationary phase is used. And the third type of chromatography for the solid stationary phase, ion exchange chromatography. So the solid stationary phase is ion exchange resin we take, and the mobile phase is liquid mobile phase. Coming to the second category, liquid stationary phase. Here you're having examples of paper chromatography and HPLC, high pressure chromatography. Okay, and here in the paper chromatography, on the paper, we are the stationary phase, here the liquid stationary phase, and thereby the liquid mobile phase is used. And for HPLC, the column is prepared, the liquid phase is the stationary phase, and the mobile phase itself is also stationary phase. And the mobile phase is also the liquid. Same, just like the stationary phase and the mobile phase, both of them are the liquids. Okay, so this is about the classification chromatographic methods. Classification of the chromatographic methods. So you have taken the liquid and this solids as a stationary phase, and the liquid is the mobile phase. Now let us switch it to the next type of chromatographic method. If gas is the mobile phase, so generally the mobile phase is always in the type of the liquid or the gas, because there should be mobility. If a solid is taken, there will be no mobility. So never we prefer the solid mobile phase. It's not at all taken. Okay. And similarly, the gas is also not taken as a stationary phase. Never it is stationary. Now coming to the second type of methods, gas mobile phase. Gas mobile phase. In this gas mobile phase, solid stationary phase is taken and gas is the mobile phase. So in the solid stationary phase, gas chromatography is an example where solid is the stationary phase and gas is the mobile phase. Now coming to the gas mobile phases, liquid stationary phase, if you take, the type of chromatography is gas liquid chromatography, GLC. Liquid is the stationary phase and gas is the mobile phase. So this is about the classification of the chromatographies. Now, what is the principle behind this one? Coming here, the principles are chromatography usually consists of mobile phase and stationary phase. Mobile phase refers to the mixture of substances to be separated in a liquid or a gas. The stationary phase is porous solid matrix through which sample contained in the mobile phase percolates. So it consists of a mobile phase and a stationary phase. Mobile phase refers to the mixture of components to be separated and dissolved in a liquid or a gas. And the stationary phase is porous solid matrix through which sample contained in the mobile phase percolates. Next, the interaction between the mobile phase and the stationary phase results in the separation of compound from the mixture. The interaction between the mobile phase and stationary phase results in the separation of compound from the mixture. Coming to the types, already we have completed the classification. Types of chromatographies. One is the paper chromatography. And the second one is a thin layer chromatography. The third one is the gel chromatography. And the fourth one is the column chromatography. And the fifth one is the ion exchange chromatography. And sixth one is gel filtration chromatography. And the next one is gas liquid chromatography. And the last one is affinity chromatography. These are different types of chromatographies which can be discussed. Paper chromatography is a technique which involves placing small dot or line of the sample solution onto a strip of chromatographic paper. The paper, it is placed in a jar containing a shallow layer of solvent and it is sealed and kept aside. As the solvent rises through the paper, it meets the sample mixture, which starts to travel up the paper with solvent. Next, this is the simple way of showing in a diagrammatic way. You're starting. This is the beaker. You're having a wooden paper. Just pin the paper, and this is the beaker. And we have spotted here, and this is the mobile phase. They're having the line here. Just 5 centimeters separate. having here also a piece of wood. Here you have pinned the paper, and here the sample. Here, this is the filter paper dipped in the water, 5 centimeters in it. And from here, the mixture rises upward, and thereby the components are getting separated. See here, this is the origin, and the sample has raised in here. So distance sample traveled by distance solvent traveled. This is the RF value. The main principle here, distance traveled by the substance by distance traveled by the solvent factor. This RF value keeps the identification of the unknown compound. Retardation factor. RF value means retardation factor. So this factor governs the principle of the chromatography. It is rather difficult to separate a complex mixture of substances by single run with one solvent. In such cases, a second run is carried out by a different solvent system in a direction perpendicular to the first run. This is referred as two-dimensional chromatography. Coming to the next one, thin layer chromatography. Thin layer chromatography, it is widely employed laboratory technique. It is similar to the paper chromatography. Here, instead of using stationary phase the paper, here the stationary phase is a thin layer of adsorbent like a silica gel, alumina, or cellulose. Compared to the paper, it has advantage of faster runs. It has a better separation and choice of different adsorbents. So TLC has more advantages than paper chromatography. In layer chromatography, mobile phase is the liquid and flowing fast a thin layer of powder on the solid's support. Substances that are less attracted to the solid are more soluble in the liquid. They move faster. And still they move faster up to the plate by the time that the process has been stopped by taking plate out of the liquid. So larger is the RF. Just see here, container is taken and the solvent is solvent mixed with the sample is kept in the bottom. So above we have kept a filter paper, and instead of paper here for TLC we have taken a thin slide. Yeah, and it is coated with the thin layer of the adsorbent stationary phase. And when sample is kept at the bottom 5 centimeters above and the mobile phase, it is dipped in the mobile phase. And thereby the solvent rises along the adsorbent stationary phase. On the thin plate, on that slide, a small, with the syringe, the drop is kept there. And thereby, if you see, as the mobile phase is moving from bottom, the container, along the slide, even the compound mixture gets separated out, even that gets moved. One which has more retention absorption stays here, and one which moves faster along with the mobile phase gets separated. So RF is equal to distance moved by the stationary phase, the component, by the distance moved by the mobile phase. See here, after that, yeah, you have prepared the plates and you have kept it in the chamber, and by locating agents we locate it. See, TLC involves absorption or partition of the solute into solvents. The level of solute determines its separation. The solute moves along the surface of the adsorbent, hence on the glass plate, and interacts with the adsorbent. Depending on the substances to be separated and the nature of the adsorbent, solvent is to be selected. Mixture of two solvent gives better separation than a single solvent, and polarity of the solvent can influence the relative flow of the solute. And the advantages of the TLC than paper is TLC is simple. It can be performed on the analytical scale as a preparative scale. Because it fits rapid speed, TLC can be employed for checking the course of chemical reactions in the laboratory. Because of its great resolving power, TLC can be used for detection of adulteration of foods, products, decomposition of the foods, drugs, and improper storage and handling. It has a high sensitivity. Detection of the compounds are encountered in the traces like drug metabolites, the narcotics, pesticides, and air pollutants. The advantage of TLC is low cost of equipment, speed and rapidity, simplicity of the method, sharpness of separation, sensitivity of detection. And sensitivity of the detection. First, what you do is you have prepared the thin layer plates, applying slurry of the adsorbent on the surface of the clean glass plate. And application of the sample is done on the plates. There you select the choice of the adsorbents, selection of the solvents, and we take the locating agents after development of the chromatogram. So sample containing some amount of the sample solution containing few milligrams of the sample per ml. It is prepared. It is applied with the capillary tube from 2 centimeters at the edge of the plate. You can see. See here from edge of the plate you can see. And the later the plate is dried. The plate is dry. The TLC plate is dipped in the developing solvent and it is covered tightly with a lid. Solvent moves against the gravitational force in the upward direction on the TLC plate. After the solvent front reaching the required height, the TLC plate is then removed from the chamber and the solvent front is immediately marked with the pencil. The TLC plate is dried and locating agent is sprayed on the locating spots. The components of the mixture is located under UV light. And the dried TLC plate is exposed to iodine, giving the brown spots. Okay, and thereby we can detect it. See, and there are many applications for the TLC. Before going to gas liquid chromatography, TLC has more advantages, applications, quantitative analysis due to high sensitivity, alcohols, glycols, amines, vitamins, amino acids, purification, isolation, identification of organic compounds can be done. You can check the distillation fractions and purification of the distillation by distillation. Various stages of organic reactions, you can assess the completion of the reaction. It is helpful in the chemical taxonomy. Now, coming to the gas liquid chromatography. In the gas liquid chromatography, sometimes known as the gas liquid chromatography. And it is a separation technique in which mobile phase is the gas. It is a method of choice for separation of volatile substances. or the volatile derivatives of certain non-volatile substances. Stationary phase is an inert solid material that is impregnated with non-volatile solvent. In the gas chromatography, a sample is rapidly heated and vaporized at injection port. A sample is transported through the column by mobile phase. It is consisting of the inert gas. Sample components were separated based on their boiling points, relative affinity of the stationary phase. And this is most often viscous liquid wax within the column. The higher of the component's affinity for stationary phase, the slower it comes off the column. The components are then detected and represented as a peak on the chromatogram. The mixture of the volatile material is injected, and thereby the mixture of volatile material, it is injected into the column along the mobile phase. The separation of volatile mixture is based on the partition of the components between mobile phase and the stationary phase. Hence the name gas chromatography. We have got gas liquid chromatography. So there is separation of volatile mixture based on the partition of components between gas mobile phase and liquid stationary phase. So it is gas liquid chromatography. Next, in the gas liquid chromatography, the mobile phase is unreactive gas. It is flowing through the tube. So we have taken previously, next diagram I'm going to show. So the nitrogen is the mobile phase and it is unreactive. It flows through the tube. And the stationary phase is involatile liquid, hence the particles are on the solid support. Now, just see the animation here. The red molecules are soluble in the liquid and they are less volatile. Coming to the green molecules, they are, even these are the molecules that are somewhat more volatile. They're coming out fast along with the mobile phase. Red molecules soluble in liquid, less volatile, and they're coming back. Green molecules are, green molecules come later. Once in the practice, the column is contained in the thermostatic oven. About 1 ml of the, see here for the gas chromatography, how you are doing the process I'm explaining. About 1 ml of the liquid is injected into one end of the column. Each component reaches the other end. It is detected and registered on the chart recorder. Retention time is a characteristic for every substance. The column may be the same, temperature and gas flow, etc. may be same. But the retention time is a characteristic. The area under the peak indicates the relative quantities. Here you can see the gas chromatography, nitrogen cylinder. Here we are having injection port, Tarak. Here we can see the gas chromatographic instrumentation part. We are having the nitrogen cylinder. The nitrogen gas, unreactive gas, is the mobile phase. And injection port. Here you are having this injection port. This is for the sample injection. And this whole part is the column where it consists of the stationary phase. And this is maintained at thermostat by the oven. And the detector, it detects whatever compounds are getting separated. And recorder will record the chromatogram. So this is the way you do. So this is first the sample is injected. This is the experimental setup. Sample is injected from through injection port. It goes along the column, which is having stationary phase. The column. As the sample moves on along the column, stationary phase, which is maintained at oven, and the nitrogen gas, it is the inert gas, nitrogen gas, and this is the mobile phase. After the sample, along with this one, even the mobile phase moves on and separates the components in the mixture. They are detected and get recorded. See how here is the cylinder. This is the injection port. Sample is injected, moves through the column, gets separated as going through the column. Here it is recorded, detected here and recorded here. Now what is RF value? Distance moved by the substance by distance moved by solvent front. For substances that are very soluble in liquid, RF value is almost to 1. And for the substances that are very less soluble in the liquid, they are very less insoluble in the liquid, RF value is almost 0. Next, what are the applications of chromatography? Coming to the applications, used in the quantitative analysis due to high sensitivity. See, in the organic chemistry, you can go for the purification, isolation of many organic compounds like acids, alcohols, glycols, amines, vitamins, amino acids. And it is used for checking the distillation fractions as previously discussed. And it is used to verify the organic reactions, how the reaction is going on, and what are the byproducts that are formed, what are the intermediates, what are the stable compounds formed, and it is helpful in the chemical taxonomy also. This chromatography, it is used for separation of the amino acids, proteins, carbohydrates. It is used for the analysis of drugs, hormones, vitamins. It is helpful for quantitative and qualitative and quantitative analysis for the complex mixtures. Quality, you will be finding out what are the components present. And in quantity, you'll find out how much is the component present in the mixture. This technique, it is useful for determination of the molecular weight of proteins. So I hope you have understood today's class. Just will have a look on briefly and end the class. In today's class, I have discussed about the what is chromatography, what is the principle behind the chromatography, and what are the types, what is the classification. Yeah, the chromatography, chroma, to write, laboratory techniques for separation of the mixtures. When the mixture is used, carries out the 3 important terms are the stationary phase, mobile phase, and the component mixtures. Coming to the in chromatography, we've seen how why we are doing it. And we have seen the classification. Know about the choice of the adsorbents. The choices are listed depending on their adsorptive power. sucrose, starch, talc, sodium carbonate, calcium carbonate, calcium phosphate, magnesium carbonate, magnesium, lime, activated silica, silica acid, activated magnesium silicate, activated alumina, Fuller's earth, and the binder is generally plaster of Paris. These are the different adsorbents. Selection of the solvent depends on the nature of the material which separation is being done. The more polar solvents produce greater migration and high better separation. So polar should be more preferred solvents. Depending upon the polarity, the solvents, how they have to be selected are, it depends upon the nature of the material in which separation is being achieved. The eluting agents is PLC are listed. So solvents what that can be used are petroleum ether, carbon tetrachloride, cyclohexane, benzene, diethyl ether, chloroform, acetone, ethyl acetate, methanol, pyridine, ethanol, glacial acetic acid. These are different solvents that can be used. And for locating agents, iodine, sulfuric acid, potassium permanganate, chromic acid, nitric acid are the locating agents that can be used. And stationary phases, you can take aqueous phases, methanol, glycol, glycerol mixture, kerosene dimethyl fluoride. Those examples you can take. Mobile phases, generally, if you mix, the more separation can be done. Butanol, acetic acid, water in different ratios give good mobile phase. Isopropanol, ammonia, and water, even this mixture gives good mobile phase. Okay. And paper chromatography also you're having different types. Classification I've told you. And paper chromatography, thin layer I have given you the brief introduction. Gas liquid chromatography also I've given you brief introduction. And paper chromatography you're having descending paper chromatography, circular paper chromatography, and ascending paper chromatography technique. So you are having one dimensional and you are having two dimensional also the chromatographic techniques. So in the column chromatography, you're having dry packing, wet packing, adsorption process, and elution. So it is helpful for more polar, less polar alkane separation. Cis trans isomers can be located. And you're having even the ion exchange chromatography. So the charged molecules in the sample are getting separated by electrostatic attractions when passed through the resin. So in the you're having resins, three types of matrices can be used in ion exchange resin. In the ion exchange resin, three types of process: ion exchange resin, ion exchange cellulose, ion exchange gel. These are the different types of matrices used in ion exchange chromatography. So natural ion exchange resins are zeolite, zirconium phosphate, lignin. Okay. So these are the different types how you do the chromatography. You're having anion exchange resins, cationic exchange resins, and we are having different applications. Similar type of ions can be removed, interfering radicals can be removed, hardness of water can be removed, complex demineralization of water, lanthanide separation, purification of organic compounds, separation of sugars, separation of the amino acids. All these can be employed for the chromatographic applications. So I've told you, and coming to the detectors, we use thermoconductivity detector, flame ionization detector, electron capture detector. Okay. So different types of detectors can be used in the chromatography. Pumping systems also, we are having sample injection port. The different parts are there. Columns, guarding column, detector, records. all these are the ones. So what is RF value? So what is RF value? All these can be discussed, and they are discussed. So RF value, it is a distance traveled by given substance. It is a distance traveled by the solvent fluid. So this is the principle depending on the partition coefficient and the part and retention factor, the components are getting separated. So what is chromatography? A brief introduction is given. And what is TLC? A brief introduction is given. So what is the classification? What are the types of the solvents? What are the types of the stationary phases? And what are the detecting agents? What are the applications for this chromatographies are explained in this session. So I hope everybody have understood today's class. And this is end for today. Thank you, everybody. Yeah, I've told you all this.